Alright, good evening everybody, it's Paul Daniels here and What I Fix Daily. Today we have something a bit different. This came in a couple of days ago, and basically the person said that I got some water on it, stopped working properly, and now they want me to fix it. Now, a couple of things. First off is when I first looked at the chassis, it wasn't really that water damage, so I wasn't sure if it was going to be that at fault. And the real thing that got me going was when I looked at the front panel, and I see here just what you want to see in Australia for 110 volts AC. I'm thinking, oh, well, okay, maybe they imported it and someone did some changes. But I open it up, and on the transformer here, you probably can't see it, it says 110 volts. So that's a bit of a concern for me, and I'm wondering if most of the problems have come about because this transformer is 110 volts. So if it's been having 220, 230 put in it, your DC voltage output's going to be twice as much effectively, which of course is going to strain the circuit a fair bit. So most of these circuits usually run around about 12 volts. For the bigger boards, they can be 24 volts or more, but in most cases 12 volts. So that's my theory, and I will show you what happened to the board. I think it's more a case of coincidental type events that give... Oh, here we go. This is the water damage effect. That nice little orangey color is from rust. So this is a Australian 2-pin, no grounding pin, to United States 2-pin. Physically, that's fine, you can do the conversion, but it does not obviously change the voltage. Alright, so that was the first thing that struck me. And seeing the transformer with actually 110 volts written on it was a real winner. Oh, I've just lost one cable, crikey. Yeah, cables are breaking off everywhere here. Alright, let's have a look and see the damage. Some of you might have spotted another bit of damage too. We'll look at the main ones first. So check it out. See that? Now that's not really what I would call water damage. I'd call that excessive voltage damage, and lots of it for a long time. And it has basically just burned the daylights out of this board. Not really sure. Yeah, maybe water did get on there, but I just can't see any significant remnants. There's a lot of scratching on this board too. So these are all the lines that go to the 7-segment board. It's quite a build up. It's burnt all the bonding there. There's no way I can't get this off. It's all one piece. The resistors, as you can see, have shedded their outer paint and revealing the wrapped resistance. I'm not sure if these are wire wound. I don't think they'd be explicitly wire wound, but who knows. Everything else looks fairly intact. We've got ourselves a big fat PIC 16 F877. On the other side of the board, we can see it's again taking a fair bit of a beating. Some really nasty looking lead-free solder by the looks of it. What do we got? One of the pads has come off. That might have been someone trying to pull that out. I don't know. These are all pretty much on the verge of snapping off. Thankfully, on the other board, they seem to be intact. So we've got a buzzer on here. What else we got? LM393. IRF Z44. Tip 132. We've got a regulator here. I think this is a 7805. Wouldn't be surprised. Yeah, 7805. Here's another fault. That cap, which is on the way out. That's a 25 volt. Now this leads me to think that it probably was indeed running at 12 volt, or meant to be running at 12, but with the transformer being hit with 240 instead of 110, it would have been putting out close to 24, 25 volts and sort of accelerated the demise of that. We've got a discrete diode bridge there, and this here is for the front panel. These two here, what have we got? ULN 2003. These are Darlington drivers. I'm fairly sure they are open collector types. So they're kind of like what you would consider N-channel MOSFETs on the low side of loads. Let's see, so what have we got here? BD 140s. What are you being used? These BD 140s, I would say, we've got 3 of them there. We're next to this here, which goes off to the board. They would be the high side power switches. So what's going to be happening? I'll change back. What's going to happen with this circuit is that we've got, get it all the way up. We've got our 3 segments here. And if we flip it over, most of the lines are all common, except for down the bottom here, we've got 3 lines, and they only go to one each of the board there. So they would be the positive, let's say 12 volts, coming in to supply to the individual segments. And then all of these connect to one segment each on all 3. So it's like, I don't know, say purple there is that segment on all 3. So what happens is you individually supply power to one of the LED modules, and then you open up the transistor, or you make the transistor conduct on the low side, so the power will go through the segment, out through here, and down through that Darlington driver, and to ground. You complete the circuit, and that segment will light up. And the reason why we have these 3, one for each module, is so that if we don't, and we had them all connected up to the same power, then anytime you complete the circuit on one of the segments, then all 3 of them would light up. The other problem, so what we're doing here is we're multiplexing, at least I'm guessing that we're going to be multiplexing. So you will drive one of these first, and then you go to the next one, then you go to the next one. The other way it might be being done, if this is somewhat more advanced, and it could be with this, is if you have a segment that is common between multiple digits, like basically if say on these 2, this segment here was on with both, then you can supply power to both of these, and when you open up that, it will then cause power to go through both, light up, and then back out. I'm not sure if it does it. It probably won't. The reason why I'm thinking that is because looking over here, we have all our segments connected up to these burned out resistors. And the reason why I'm thinking it probably isn't done that way is because if you drive 2 segments through the same resistor, then the amount of power going into each segment is then roughly halved. I say roughly because no two diodes are identical. And that would give you the interesting effect of some of the segments would be dimmer versus the others. So perhaps probably not being done like that. It is most likely just being scanned like 1, 2, 3, 1, 2, 3, 1, 2, 3, and then switching the segments accordingly. It's very simple. If you do it fast enough at a couple of kilohertz rate, then the human eye won't pick it up unless you sweep your gaze very quickly and you'll see a bit of jittering. So I guess for now, what we're going to have to do is we're going to clean up this. At 12 volts, I'm going to have to guess what all these resistors are blown. At 12 volts, these are usually around about 7.5 volt segments, because I think about 3 or 4 LEDs in them. And we have the high side switch, so let's say half a volt. We have the Darlington, we'll call it half a volt there. It's not really right, but so we've got 1 volt through the transistors loss, and usually we drive these at 20 milliamp constant. Now this is where it's going to be a bit of a guessing game. I might start at 20 milliamps. So at that, it's 5, let's say 5 volt. We're going to have to drop 5 volts to the resistor. And at 20 milliamps, so what is that? That's 200 ohm. So we go for 200 ohm resistors and see how it looks. Assuming nothing else is really bad, we'll have to replace that. And what I am going to do with this for the reasons of safety is I'm going to convert this from a in-housing transformer. So we've got this 110 volt transformer. I'm going to instead replace that with a DC jack, and we're going to just put 12 volts DC plug into there straight onto the board. That makes it a bit safer overall because, I don't know, I am not suitably qualified on the 240 volt side of things. I don't know if this is appropriately designed. We don't have no ground coming into there. So if this happens to break off, starts touching that chassis, the chassis comes live and you become the ground. So that wouldn't be very nice at all. At least that's my understanding of it. So the way to get around that is we just do the conversion outside of the case at 12 volts, bring it in just like a normal safe DC connector. I'm going to assume these, what's going on there? Oh, these are just breaking off, so we've got purple, blue, green. Alright, these, from what I can see, these do match 1 to 1. So we'll just have to cut that off, put a whole new connector in. What is this? 1, 2, 3, 4, 5, 8 pin connector. What have we got there? We've got 8 pins there. Should be good. Just 0.1 inch separator there. So we're going to clean up that whole area, redo the cable, redo that capacitor. Fingers crossed, it might work. And of course, all this is riding on the assumption that we are actually getting 12 volts in. I'd be surprised if it wasn't 12 volts. We've got a 7805 here. Dropping more than 12 volts in there, that would be asking for a lot of heat to be dissipated. In fact, I'm surprised that isn't looking more charred up. But probably what saved it here is that even though it's a big display and we are doing 20 milliamps per segment perhaps on average, it's still only 140 milliamp. Whatever this circuit takes, let's say another 50 all up, that's pretty generous. So we say 200 milliamp. See at 12 volts, and we're dropping down to 5. Yeah, I really hope this is 12 volts. It's pretty standard. I mean, I can't imagine it being 9 volts. 9 volts wouldn't really give them enough to get good clearance on the overheads required for that driver. The decimal points on it might be a bit of an interesting thing. They only have usually 2 diodes in there, so probably needing a higher resistor, maybe something like 390 or 480, something like that. We can experiment and see how it goes. Alright, let's just give it a shot. Now let's just go with some, let's just go with trying to wick these out. Come on. That's a great way to waste a lot of wick. I could use a solder sucker, but the trouble with the solder sucker is it's going to damage the pads and they're already pretty beaten up. Let's try to get some of that off through just picking it up with the soldering iron like that. Yeah, that pad is well and truly cactus. Yeah, you're out of here, buddy. go through this stuff a mile a minute. Come on. Come on. Really not a fan of pin through stuff. There we go. Now that is just a mess. Glorious mess. I wonder how long that's been brewing like that. We'll get these persistent pins out. As a kid, I remember when surface mount first sort of started showing up in kits. I think it was a company called Talking Electronics who made the, well, at least they proclaimed they'd made the first surface mount kit in Australia. And it was a little radio frequency bug, just a FM radio. I remember seeing that thing and thinking, this is fantastic. This is far better than dealing with the dodgy pin-throughs crap like this. Yeah. I mean, I know pin-through has its place, but I am genuinely glad to see its demise as a general rule. I'm trying to think of this. What I might do is clip the legs on all of these. Like so. And that makes it easier for me to get the bits out one by one. But the whole set it up, flip it over, clip the legs. Oh, you know, it was just no fun at all. I'm gonna put some flux on these. Maybe they'll let me pull them through. It was always interesting to hearing the people complain about, oh, surface mount's impossible, no one can do that. I was like, bring it, I'll have it. So, really, you gonna survive, mate? Come on, buddy. Yeah, you survived. Just. Wow, that's a rock. Sorry about the shakiness. In this case, my fingers are priority. You're out. You're out too. Wow, looks like a bunch of very dead ants. Check that out. I wonder how carcinogenic that stuff is, and yeah, maybe there was water down there. See how it's rusted, whereas the just couldn't really see any liquid indicating. Yeah, normally you'd expect some sort of fringing from the dryer. Yeah, get them out of the way. Oh, we've got one left attached. Assistant or blighter? Who are you? You're... There we go, edge on, gotcha. Now we've got to get all these ones out. Same thing, we're going to just flux it up, and these ones I should hopefully be able to just push the leads through. and have them drop out. Sort of like this. So, come on, there you go. See? And the nice thing is the little J tip goes right on through. Good on, that's brilliant. Ah, mate, didn't get it right. Now, for a few of you who've been watching the Lewis Rossmann streams and you've been seeing the multimeter software that I did for him not quite working right, it's coming up with millivolts, or what appears to be millivolts when it should be volts, and kilovolts occasionally, just for fun. Now, Lewis gave it his best shot, trying to sound a bit Australian when he's saying mate and crikey. Well, yeah, it was a good try there, Lewis. Oh, whoops, that's actually a connected one. I think you were faking how bad you could do it. I'm fairly sure you could do a better job. But, there you go. For reference, I am not actually a good reference for the Australian ochre type, I could just say, accent. Mine is a little more British orientated, so do not use me as a reference. But that said, a lot of Australians sound more like me than they do what they are portrayed as in a lot of media. We don't all go around saying, "Oh, g'day mate, how's it going? Yeah, just see that footy the other day. Oh, blimey mate. Well, anyway, gotta get my dunny door and go for a fang down the road. Get me some Maccas. Sheila ain't happy with the way I'm doing the Barbie lately." So there you go. That's about the best I'm gonna do for you. I'm sure Dave Jones just cringed and died listening to that. I'm probably going to get a threatening email saying, "Paul, what are you doing, mate? Don't go spreading false styles of Australian speaking." So yeah, there's a fair bit of diversity in the Australian, just same with the American, or any country for that matter. Alright, so we've got our burnt resistors out, and we've got our burnt connector out. And let's see, these ones here, yeah, they're going to need a little bit of tender loving care. I will probably replace them with wire, because I can't see them really being dependable. I'll try and hold them down, but yeah, not a lot of confidence in that. These ones are pretty good. Give this a bit of a wash down. One of the problems I'm going to have to deal with is I'm not sure which one's going to be the decimal place. I try to find a data sheet for the LED module, and I couldn't find a damn thing. I'm also a little worried the carbonisation of that circuit board there could be somewhat conductive, so we'll have to have a look at that. I'm hoping it's not, but well, what you hope for and what you get don't often end up being the same thing. We do get a fair amount of United States equipment, or 110 volt equipment, that people have been using on the Australian 220, either through transformers or something like that. It almost always ends up in drama sometime down the track. Yeah. That's really not very pretty. Certainly could be a lot worse. Just try a bit of scrapey. On the upside, these are single side boards, so you can just go absolutely bonkers with your scraping and cleaning. You're not going to rip up any tracks. At the very worst, you might just scratch away some of your component indications. Screen printing. Oh, look at that beautiful muck. I'm just going to do a resistance test on some of these charred areas. I'm using my good old Protec meter here. Wrong connectors, buddy. Straight away I'm reminded why I switched to the other one. So open circuit, which is what we want. So we're not showing any conductivity, so that's good. Beauty. Alright, now we just need to put in some resistors. I'm thinking 220, 200, something like that. I'll have a look at my little box and see what I've got. Alrighty, let's have a look. 2 ohms, far too low. 2 ohm, 2.2, still too low. 10k, all high. 20, still a decade down. 220, but 0.4 watt. Ooh. So we've got the right resistance, but the current going through there probably make a real mess of them. 1 ohm, definitely not. 150, yeah, they're the small ones too. I'm not going to have a good day today, am I? 11 ohm, who buys these things? Clearly I do. 330k, nope, you're out of here. Oh man, I can't even... What? I'm getting old, I can't read this faded label. Geez, give me 330 or something. Give me something I can use. What are you? Are you... You're red, you're 22 ohms. And you are another 2 ohms. What? How can I not have anything useful? Well, bring out the multimeter and have a look and see what one of these are. Man, you'd think I'd have 220s lying around. I mean, I guess I do, but they're just the wrong wattage. And I'd be stressing them a little bit if I ran them that hard. Come on, come on. Oh, damn you. 22 ohms. And since I don't know where I got that from, I've got to throw it back in the box randomly. I'm pretty sure it was this one. Doesn't matter, you're in the random pile now. I'm thinking I must have another box of resistors somewhere, because these here are 0 ohm link resistors. And I know I bought a spool of 1,000 of those, and they're not in here, so that means they've got to be somewhere else. 330k. You're killing me. 11 ohms? Really? You say 11. Oh, you're brown. Brown and red on a blue foil wrapper look very similar. Alright. So we got 220, 0.4 watt. So what sort of power would we be drawing if we did use those? Where's it? pen and paper. Alright, so we're proposing 5 volts dropped over the resistor at 20 milliamp. Well, that was our theory. So now we know we're just going 5 volts over 220 ohm resistor. Geez, Paul, come on, mate. Let's see, power equals V squared on R. So power equals 525 on 220. Which, well, it's a little more than a 0.1. So it's 100 milliwatts. So I could theoretically do it. You know, you guys are not even the right ones. Yeah, you could theoretically use those because they're 0.4 watt rated. I guess we could try. We don't have anything else at the moment. I'll order some if I need to. The other thing to note is that they're not constantly on. So given that we're switching between 3 different digits, they're going to be on 1/3 of that, so that drops you down to about 30 milliwatts, and all of a sudden it's not such a bad idea. One convenient thing about using legged parts is that they're usually always magnetic, so you can clean out your bench just by running a magnet over it. Right, we've got a nice festering mess now. Okay, 220s. I guess I would feel more comfortable if they were 1 watt rated. And we've still got to deal with the connector afterwards anyway. We're going to need 8 of these. 2, 3, 4, 5. They're pretty diminutive compared to what we just had. Oh man. I haven't got a component lead folder anymore. I don't need one really. I'm just something that everybody had in their little toolbox, component lead former. Now nobody really wants those things. I'm going to leave them a little proud so that they can dissipate, though really that's pretty pointless to be fair, because even if these things are right against the board, they're so small that power's just there. Oh dear God. Did I tell anyone that I don't like doing pin through parts? Did I? Now look at this. Look at all this time that I'm wasting where I could, if it was surface mount, just drop it on, solder it, we're done. Where you at? Drop 8 of them on there. Hit them with the hot air and we're done. This is where you use a resistor network. I suppose a resistor network to handle that sort of wattage is a lot more expensive than just individual ones. Although they have got resistor networks here, but maybe that was more keeping the board size under control. And last one. You watch, all of these are just going to go pfft when I apply the power. That'll be fun. Stuff is all. I'm pushing it to the board. Maybe I can put some Arctic silver on there, liquid metal, and whopping great big heatsink, and a fan, a nice big fat 120mm fan. Yeah, get the overclockers onto it. The other problem is the... Oh great, the leg's gone through. All the little solder ends, just after you clipped them off, stabbing you in the finger. Let's get some lead poisoning. I think my eyepieces are a bit foggy. I can't really get a proper look on that. These resistors are old. They've got corrosion on them. I forgot to do what you meant to do with legged parts. You're supposed to run over them with about a 1000 grit, wet and dry, get that corrosion off. Another reason not to like pin through parts. I mean, I know the same corrosion applies to surface mount, but it just doesn't seem to happen that same way. Yeah, I mean, look at that. That's just very dissatisfying. At least the corrosion. The good old Amtech is doing its job. Okay, we're gonna have to redo this one here because, as you can see, it pushed the pad off. It's okay, we'll work around that. Let's put some more Amtech down. Can you imagine Chip Quick trying to do this? It'd just cry and give up. Anyone remember the old aluminium clamps that you used to get to put onto the leg parts? Particularly transistors. I'd be like, now don't get your transistors too hot. Use an aluminium leg clamp to keep it cool. Nowadays we just sort of go, let's just put 390 degrees centigrade onto that and hot air it for 5 minutes. She'll be right. There we go. Legs flying everywhere. This is a real university party. Oh yeah, you just jumped off, I felt that. I'm gonna have to redo you. And you. And you. You little rats. Seems like these legs aren't magnetic. Just another reason for me to hate it. If the output from these LEDs is just too dim, then I'm going to have to actually go the other way, and we'll go to about 1/3 of 220, something like 72 ohms, just something around the 60-70 ohm mark. Alright, so I'm going to clip this off about there. push him through. Like so. Come on. In you go. Put that back over there. And then push back from the other side. Yeah, I felt you just popped up again, didn't you? Can't help yourselves. Come on. There we go. I can see myself putting a fair bit of coating on this. Well, have I got a crack there? Oh no, she's alright. Oh, what have you done, Paul? What have you done? Tried to make it better, but you made it worse. Alrighty, so now we need an 8-pin plug and header, socket, whatever. I do not have an 8, but I do have a pair of 4s. Now I just want to check. See on these other parts of the board, they've got the extra line at the back of the connector outline, which implies where the clip or the lock plate is. And we are just following the same pattern here. Good to follow the same pattern. Yeah, see there's confirmed again. Well, this one. So at least we know we're using their rules. Now using the dual 4 does mean that I have to do the same on the connector from the LCD, the LED, but that's fine. We had to rewire that anyway. Some sweet looking joins there. Except this one's going to be unfortunate. It still works. Marvelous. Oh wow, how's that for fluky luck? I got all of these orientated the right way. They're just looking really terrible. I'm sorry, I'm ashamed of these, but yeah, and I've got to bond these down. I really am ashamed of them. I put a great big blob of something over there. They are not pulled tight or anything, they're just flapping around in the breeze. Right, now we've got to do the connector. Actually, I might do the big fat capacitor for now, so what are we after? Like a 2200 microfarad probably. 2200, 25 volt. So where's our positive? Okay, negatives towards the diode array. Alright, let's just get this one out. Naturally out of focus. There we go. I mean, it's not really bad, but that's definitely pushing up. Okay, back from that little intermission called dinner at 10 o'clock at night. So we've got our 4-way crimp connectors. We've got a replacement cap. Now this is a 2200 microfarad, but this is only a 1000 microfarad, 25 volts. Strictly speaking, it's not even really required. The reason being is because, remember, we are going to convert this to being powered by a DC supply. So the brick that is on the outside that's going to be supplying the 12 volts that we're taking in, it's already filtered everything. So this is really more of just well, doesn't really have any great purpose. Just gives it a little bit more local filtering, particularly with the switching of the LEDs. There's going to be a bit of current draw there. I mean, not massive, but anyway, we'll get this. What am I doing? Oh, I'm going for the wrong things. In fact, the whole diode bridge assembly, all that sort of stuff, that can... Why haven't I got my... There we go. There we go, much better. Yeah, the whole diode bridge and all the AC input section converting to DC, that can all technically go. But I'm leaving it there for the sake... It's not going to do any harm. So we'll lose, you know, a volt or two off the 12 volts through the diodes. But again, it doesn't really matter. And if it does, we'll just compensate. I think we should be right. That is a very expensive capacitor for this board. It's one of my low ESR ones that normally I use for motherboard replacements for high surge currents. Tremendous overkill for this task. Yeah, that's good. Well, now we need to do our 4 connectors. 2 connectors, 4 each, and we just have to try and keep our colouring all the same here. Oh boy, you are a mess. So we got purple, blue, green as our first 3, purple, blue, green, and then yellow as our 4th. Cut these back a bit. Wow, that's really messed up. But, so I'll trim these back a bit more. There we go. Now I need to get a crimping tool. What's the upside of crimping is that you don't do any soldering. At least you shouldn't, theoretically. Oh man, I wonder if this thing even works properly. I don't know what its settings are anymore. I'm making a royal mess of this. Crimping is not my thing. I admire people who have the tenacity to sit there and manually crimp things. Not for me. I think 8 will be my limit for the year. Ah, boy. Probably half the drama is simply the fact that I don't have good type of tools to do the crimp. What's even worse is I don't even have the... Wow, I can barely see anymore. Holy crap, that's bad. I don't know what gauge I am. This one looks better. This one has got nicer looking fold. Right, like that. The other problem is that being left-handed, everything's backwards. Upside down or backwards, take your choice. Looks like I've already fucked that up. Looks like I've already messed that up. Really? As I was saying, I admire people who can crimp. Oh, you're kidding me. Would help if I had better light in here for this particular task. Because even though my eyes aren't that great, if you get at least a nice amount of light in here, it gives you a chance for your eyes to focus a little better. So this is supposedly 26 to 28 gauge right at the end, whereas this one offers me 28, 24, 20. Right, 24 to 20, maybe that's what we want. Nope. Seriously, who invented crimping? Fortunately, at least I do have about a box of 1,000 of these various connectors. Very old stuff that I got lying around. Might help if I just sort of like shake that just a little bit, just to grab it like that. Okay. This is definitely where left and right hand is going to bite me. Okay, so I need to come in from the other angle. Let's have a look now. Oh, there we go. Much better. A little bit crushed there, so maybe I need to drop back a bit, but that's done the job. Looking good. Bit of a mess down there, but looking good. Well, I suppose I should, well, let's see what we can do about testing this. Well, at least our polarity is not going to matter, since we've got AC coming out of here, so we can just clip this off. And we can use this as our test lead. I'm probably going to need this front panel, but let's see. We should clear up a little more. Get this wick out of the way. Oh, connectors out of the way. And by out of the way, I mean on the other side of the bench where you can't see anything. I need to buy myself another set of these leads. These are a Rossmann set. I think it cost me like 30-40 bucks Australian, but they're just so convenient because they come with these hooks. They also come with some really good alligator grabber clips, which I can't seem to see anywhere, and of course they come with what you've seen me use most of the time, which are these very sharp pointy probes. And the cable's nice and flexible, and you can nest in another one. Let's get this right. That's the speaker, so we obviously don't want to put power into that there, else we'll create a bit of a no-no. You guys, maybe you want to be alligators. Great, you're going to make me have to find those. Okay, what I love about these alligators is that they're very flat. So they're not your typical cheap, nasty ones that just chew through everything rather than grabbing anything. So these have a nice flat surface that lets you get a nice grip without breaking everything. And they've got a little bit of insulation around them, so they're shielded from each other. Alright, yabba yabba yabba. Let's get on with it. Let's see if this even works. First test, I'm not even going to try and hook it up to the panel. It should just turn on, my theory. Should really disconnect this until I set the voltage. We are going to go for 12 volts. Yeah, 11.9 is fine. And just for the sake of protection, we are going to go with 200 milliamps max. It's still 6 watts that could come into there, so yeah. Okay, everybody cover your eyes. Here we go. We've got a funny number there. I don't know what that is. Something. We've got bad connections. But I will tell you this much. It's not getting hot, so I think our resistors will be fine. That's it. That's not really the sort of display we want. So let's try plug in our front panel. I'm guessing that's upside down, come to think of it. Decimal point should be at the bottom. So here we go now. I have no idea what that means. Doesn't look very interesting. Well, it's doing some counting. Have we got things backwards somewhere? What did Farnsworth make this one? Okay, the previous one was 0. One way to know for sure is if the same segment doesn't illuminate on all of them. That's probably a 5, maybe. Yeah, I don't know what I'm dealing with here. Well, the resistors were definitely fine, so we know that. It's probably just our driver's a bit dead. And we know the 3... There we go. Wonder what that means. Yeah, I'm going to try something. Theoretically, we can... Let's see. I want to see if I can illuminate all the segments. we should be able to put, I think, 7 volts. We do have a risk, we don't know what the decimal point's going to be. So the way we can get around that is we set the current to 20 milliamps and let the power supply do voltage, adjust the voltage accordingly. Okay, so that one works. It's a little bright, so that's 7.9 volts. That one works. And that one does not. Phew, yeah, okay. Green is decimal point. I should write this down. So yellow, green, blue, purple, orange, red, brown, black. Okay, so yellow is segment F. Green is decimal point. Blue is A. Purple is nothing. Nothing? Nothing. Okay. Orange. What is that? That's G. Red is E. Wait, look at purple is nothing. Or at least doesn't seem to be. Brown is nothing. Black is nothing. What? Okay, I think we've got destroyed panel here. This is better if I go here. This is the next digit across. Guess that's good. Yeah. Yeah, we've got destroyed elements in these panels. Damn. Kind of kills the whole cost effectiveness of this. Purple is B. Yeah, orange is G, we already know that. Red is E. Brown is D. And black. Again, black shows nothing. Let's try to see if I look in the... There we go. Black is C. So we got A, B, C, D, E, F, G. Decimal point. So all of these modules have failed LEDs in them. Fantastic. Great. So we fixed it, but our panel's no good. Oh well. You can get... These are 70mm units. But the thing is, trying to actually get ones that are sufficiently identical and more to the point that actually fit this footprint and have the same segment setup, it may not be viable. I'll have a look. I'll dig around on the internet and see what my options are. So we revived the board. It seems to be driving things right, but yeah, something went terribly wrong there. Oh well. And 12 volts seems to do the trick for us. So we'll leave it at that, and maybe we'll come back to a part 2 later when I get fresher segments. But at least we know the board seems to be working. We can do the conversion over so it's safer DC, and that way we don't have to worry about that 110 volts and all that. I'm amazed that even worked as long as it did. So sorry, it's not a complete job, but there you go. Bit of interesting things for a Friday night. And I'll see you guys next time. Oh no, 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 I did have my audio on. Oh god, oh my god.